Tom, you still awake?
I'll be honest. I literally had a nap from
Yes.
9 until 10 p.m. I've done like 5 hours of teaching today, so it was I was feeling it. So I had a little 1 hour nap and then got back up and then sort of woke
For
myself
everyone
back
else
up. So now I'm
watching,
raring to go.
I did have a chat to Tom earlier, and I was complaining about being tired, and I'd been sat at my computer sorting out stuff all afternoon. And Tom had been, what, 3.5 hours on the trot of
Yeah,
face-to-face
back to
teaching.
back. Exactly. Yeah.
So before I
It's
give
all
too
good though. I
many,
love it. I'm complaining. I love it. Right. This is what we do as mathematicians, as teachers. We love interacting and teaching our students. So
I've given away some sordid details about how much work you've done this afternoon. So tell us more about who you are, Tom. I haven't done any intro for you. I completely forgot to do that, but you know better than me who you are. So tell us more about your background, what you're up to these days, and then we'll do some magic maybe.
Awesome. Yeah. So I'm a mathematician at the University of Oxford in the UK. I teach the undergraduate students, and when I'm not teaching, I do lots of maths talks, like most of our presenters. I actually got to do one with a live audience in September, which I'll be honest, I was weirdly terrified, despite having done several hundred talks. Like
Yeah.
going 6 months without doing one it was amazing, and I loved it. But also it was kind of like I was really nervous.
I did the same last week.
Um,
First time in a school for 6 months, and I'm like, there are real
yeah.
children out there. Well done.
Yeah. It was all, of course, very socially distanced and masks and everything. But no, it was really great to be back doing something, because yeah, we've been doing obviously things like this online. And then, of course, when not doing talks, I also do online videos. So I have my own channel, Tom Rocks Maths, on YouTube, website tomrocksmaths.com. I even have it tattooed on my arm. So
I see you have a number of tattoos there. Maybe we should talk about them later.
yeah. Yeah, absolutely. And just like Ben as well, do some number file videos from time to time, which is always great fun. So one this week on calculating the blast radius of an atomic bomb.
Oh, yes, it was on our list
On
of things we might talk about, but I suspect we have many things we need to talk about. So when I spoke to Tom earlier, you told me that you've never done maths magic. Is that true?
I have never in my life attempted a magic trick of any kind.
Of any kind,
Like not
whether it's
even
mathematics or not?
yeah, exactly. Like not even, like I guess quite a lot of people as kids, you get the little play magic set, and maybe you put a hat on and have a wand. I have never attempted a single magic trick at any point. There it is. He's got all the props.
I just realized
I've
everyone else is
never
wearing
done
a
this
hat.
in my
So
life. So I think that I'm not even sure. Well, I know why I signed up to do this, because I think it's great and wanted to be a part of it. But I absolutely do not have a magic trick. But I'm hoping, Ben, as someone with many magic tricks, you might be able to teach me.
It's just so we're clear here. Like, I'll do the thing on a 24-hour maths magic show, but I don't have a magic. I'm just going to berate you for that for the rest of your life. I think it's completely fine. And what I said earlier, but maths and magic does go together really well. They seem to be like the idea of what's going on. Why does that surprise me? Is very mathsy as well as magicy. But the art of concealing what's going on is kind of the opposite of what you do in your job of teaching. So maybe it's valid that you actually make things clear instead of obfuscating.
I don't do any of this deceit, any of this cloak and dagger type hiding things.
Well, so you asked me to supply a trick, and I deliberately, Tom and I had a chat earlier, and Tom said, don't show me the trick now, so that I can do this on you live, and we can have a chat about what it feels to see a trick for the first time, which is a little bit, I thought I was just presenting the thing, but Tom said, well, you better do the thing, and now the pressure's on me. However, I do need your cooperation, and if we do this live, maybe at the end of our segment, we can get you to do the trick live for having just learnt it, maybe, because I will reveal how this works. So if you're up for it,
yes. No. This is I'm very keen to first of all be your volunteer, and more importantly, to do my first ever performance of a magic trick in my life.
I just realized
having been taught by you.
I did promise to blindfold myself at one point. I didn't bring a blindfold with me, so we're gonna have to trust me. But hopefully, if I change my camera, you can see some well-known objects. Is that visible to you? Okay.
I can see 3 blue, very nice blue dice.
Good, and they are live dice. I can roll them. They should be rolling live for you. Is that correct? Good.
Yes, you got a 4, 4, and a 2.
Good. You can even see dots and numbers. Good. So I am going to close my eyes. Unfortunately, this makes it quite hard to interact with the dice still. So we might have some slapstick. If I was doing this live in person, I would ask you to handle the dice. But since you don't have the dice there, I'm going to try this. So just tell me if I'm pointing to the right things and help me out. By the way, my left and right is confused. So that's on my left. Is that still left for you? No, that's right for you, isn't it?
No, as I'm looking, that's my right. Okay, right.
So we're going to get very confused.
Left and right. Okay.
I'm
is this
going
the
to
trick,
shut
or is this just?
This is just the witty banter that I supply with everything else.
All right.
Sorry, banter, not witty banter. I'm going to shut my eyes now. And Tom, you're in charge of. You don't tell me what's going on. I promise I'm shutting my eyes, and I promise that even if you think I'm cheating, you could do this without cheating. So I'm going to roll these 3 dice. Are they visible to you?
Yes, I can see 3 numbers.
Okay, can you add up the 3 numbers that you can see? Don't say anything out loud, but make sure you've got a running total in your head. Is that okay? You've done that?
Yeah. It's in my head, yes.
Okay, I want you to choose one of these dice. I have no idea where they are. Is there a dice near my hand? Just stop me when you think there's a dice nearby.
Yes.
Okay, do you want me to change to a different die?
Yeah, let's do that one. No, sorry, no, yeah, pick that one. That's fine.
Pick that one? Okay, so I'm going to turn this die over and show you the number on the bottom, which I also don't know because I can't see anything. Can you see that number?
Yes.
Can you add that to your running total?
Okay, so is that replacing the old number or just adding? No, it's just
you had the total and you're adding on another number which is not visible.
Gotcha. Yeah.
And I'm going to re-roll this die so I can't know where it ended up. So has that been re-rolled?
Yes.
And can you see a number on top of that one?
Yes.
Add that onto your total as well, please.
Yeah.
So you now have a running total, and I'm going to open my eyes now because I didn't see, let alone which dice got re-rolled, what the rolls were. There's no way I can know your running total, which is interesting because you're thinking of the number 17.
I am indeed thinking of the number 17.
That is a relief.
Yeah. Okay. All right.
So this is a fun little dice trick using just 3 very readily accessible dice that you can find out of any board game. But it's a nice trick. It's one of these tricks that I think when, like all magic tricks, when you know how it works, you're like, oh, well, of course. But when you don't know how it works, like all good magic tricks, it should be like, what the fudge?
Yeah, no, well, I am thinking that, but then that was my initial reaction was as you say, and then now I'm thinking, okay, so let's think about what we did, like what's going on. I've got some ideas as to what might be happening, perhaps.
I'll tell you what, hold those ideas. I'm going to do the trick again a little bit quicker now, and I won't do it as much of the slapstick, although I will have to do it blindfolded. And if you have some conjectures, I think people watching have some conjectures about what's going on as well. So you can test it out now, but you'll see everything, obviously. And then we can talk about it. And if you're ready to reverse it, then you can tell me and I'll roll the dice and you can shut your eyes. And
I'm not sure I'm that confident yet, but we'll
we can have a chat about it first. So I'm going to shut my eyes again. We'll go quicker this time, right? You ready?
All right. Yeah. Let's do it.
I'll shut my eyes again and roll in the dice. Can you see 3 dice on the screen?
I can see 3 dice, yes.
Okay, add up the numbers, please.
Okay.
All right, I'm going to find one of them. Wait, there's not one there. There's a die there. Can I use that one?
Yeah, that's
I'm going to turn that one over. Can you see that number?
Yeah.
Add that onto the total.
Yeah.
And I'm going to roll that one again. And add that onto the total.
Okay, yeah.
Are you ready?
Think so.
Okay, so I didn't see the things I didn't see, obviously, but you're thinking of a number, which is interesting again, because your number is 21 this time.
It is 21.
I was
at one point it was 17, and then I was like, is this always 17? Is this just like Raj's trick where the answer's always the same thing? But obviously no.
Good. Well, actually, what I like about the mathematician in you was conjecturing. You start to see something unusual and you think, wait a minute, is it? No, it's not that, because now you found a counterexample. It's not always 17.
Exactly. Yeah.
So do you want to ask me any questions? I am going to reveal this trick since you asked me to, and it was meant to be you doing the trick, which you're going to do in a moment. But,
yeah, I think I need to know exactly how it works so I'm going to attempt my first ever performance.
Well, I'm really glad that you were brave enough to say, I'll try and work this out live without any preparation. So tell us what you're thinking. Any thoughts you've had about
all right.
this?
My thought was the first time we did this, so I was like, okay, so we've got 4 rolls in total.
Yeah.
No. 5, isn't it? Because it's the first 3 that get added together. Then we do the flip and add that, and then we roll again. So there's 5
So 4
numbers.
rolls, but there's another number coming from the base. Yeah.
Yes. Okay. So there are 5 numbers being added. So that's going to mean a number that's anywhere from 5 to 30. So I was just trying to get my bearings on what the answers could be. So there's a
Absolutely.
finite range, right? This is
I get you found the bounds. I like it. I like it.
Exactly. We found the bounds. So you've got a, I wouldn't say a good chance of guessing the right number, but it's not quite as ridiculous as, guessing like a 6-digit number or something. So that was my first sort of thing when I was trying to process what's going on. Then obviously the fact that at the end you can see all three numbers.
That's a really
Clearly that's important.
Good point. And I think that's a really good thing for magic sort of analysis, is like, what do they know, or what could they know, and what could they not know? And it was true that I couldn't know what you rolled on one of the dice originally or the bottom, but I do know the last three.
You know three. So I was thinking, so there are 5 numbers you need to know to be able to get the final sum. You know 3 of them at the end. And then you also know something about the flipping that took place. So even though the dice that was flipped was then re-rolled, like those, I think I've got it, because the 2 numbers, I got it, yes. this is awesome.
This is magic in a nutshell. When you know you've got it, you've got it, because you're like, oh, it's that.
That's what it is.
Yeah, and it so simultaneously feels lame and wonderful. At least that's my experience about working out a magic trick. You're like, yes, I got it, and God, it's lame.
Yeah, I mean, no, it's great. Okay, so can I try it on you without?
Please do, and then we'll settle it. We'll say it verbally what's going on afterwards. But let's try it before we reveal it. I mean, a lot of people have got this. I tell you what, if you're watching and you got this ages ago and you're thinking, "Wow, Tom's really shouldn't be at Oxford," it is amazing how different it feels under pressure with millions of people watching on YouTube. And even if there aren't millions, it is amazing what doing under pressure does to you. And if you haven't tried doing under pressure, you have no idea. Okay.
Also, I'd just like to add, I think because I don't do magic tricks, or generally, if I'm honest, it's not that I don't like magic. It just doesn't form part of something I consume in my life. So I think I'm actually at a bit of a disadvantage because I don't know like the standard tricks and things. So, but obviously I'm at an advantage being a mathematician. So.
Which I think that's why I really like to do this sort of slightly reversed version of a magic trick, which is that we get to model what it feels like to try and work it out. And you're doing this lovely. So I'm going to be the dice roller, but you tell me what to do.
Okay, so I believe to start, I'm not going to look, am I? Right, so I don't look, and then you roll 3 dice.
Okay, I'm going to put my dice camera back on. So don't look at the screen anymore.
I'm not looking at the screen.
I've rolled 3 dice.
All right. Now you're going to add up the total, the numbers on those 3 dice.
Okay.
Now you're going to select one of them.
Okay, I'm picking one of them.
You're going to flip it over.
Okay.
And then add that number to your total.
Okay, I've done that.
And then you're going to roll again.
Okay.
And then add that number also to your total.
Okay, I think I have a total in my head. You can look now.
All right, and then I can now look. Okay, and I can see, okay, we've got 3, 6, 6, so that's 12. So your total is 19.
Yes, it is.
Yes! I thought you were going to say no just to wind me up then.
I contemplated it, but that would be me because you absolutely nailed that. I can't hear everyone, but can we have a round of applause for Tom Crawford, who saw a trick cold, figured it out, and I know that a lot of other people on YouTube have figured it out. Well done, you. I can see some non-spoilers going in. Remember, spoilers don't help anyone. But Tom, you figured it out live on camera. Well done. Tell us the secret, and then I promise I want to talk a little bit about what's written all over the bits of your body that I can see.
Yes. All right. So the thing that really helped me, actually, I'll sort of talk you through how I figured it out, was actually saying there are 5 numbers you're adding together. So then to me, it's then, okay, so to know what's going on, the person, the magician, needs to know what these 5 numbers are.
Yeah.
If you know the 5 numbers, you then know the total.
It's all over. Yeah.
And then when I then realized at the end, you can see 3 of them. And then, of course, you don't know the 2 that were rolled in between because you don't know what was on that original dice.
Correct.
But the flipping trick, you don't need to know what was on it because the opposite sides of a dice will always add up to 7.
Stop. Hold that thought. There's the key, right? And there's a fact that you knew. How did you know that?
I didn't know it. I'll be honest. It happened in the first one. And I remembered that it was a 6 and then it was a 1 and then it became a 6. So the very first example we did when you were performing the trick, I saw the 1 and then the 6. And I was like, okay. So, and I just remembered what they were. So my conjecture was, do the opposite sides add up to 7?
And if they do,
and then when we did it the second time, it was 3 and 4. So then I thought, okay, so then the only other possibilities that are left, so 4 of the 6 numbers have appeared on opposite sides. So therefore it had to be true. So I didn't need to see the third trick. But I potentially, if the second time I'd had rolled a 1 or a 6, it may have actually
skewed your data collection.
Yeah, it may have thrown me a bit, because I genuinely, I don't think I actually knew in my head that the opposite sides added up to 7.
So let's finish the story here. I said it was the crucial thing. Opposite sides of a d6 do add to 7, at least if it's a standard die. It is not necessary for that to be true. You could put the number 2 opposite number 6 and you could still make a die. It would still function in a pretty similar way, but people decided to make dice like this. And you're right, opposite sides add to 7. And since they do, why do I only need to know 3 of the numbers?
Add 7. You add those last 3, and then you add 7. So you have to check test your mental arithmetic a little bit.
I tell you what, under pressure, adding 7 is difficult.
Exactly. Yeah, the first time when you were telling me to keep track of the total, I was like, oh, this is a bit late for this. Like,
so I'm curious about why dice have to be made like that when they don't. They don't have to be. In fact, I can prove they don't have to be. Here's an octahedral die, right? And the number 4 is opposite the number 3, and it does have opposites. Not every shape would have an opposite, so that adds to 7. But the number 5 is opposite the number 6, so they don't add to a constant. And I leave it as a source of investigation for anyone out there to go and investigate. Could it have a constant? And if it could, why doesn't it been made like that? But that's a sidetrack. I salute you. I've given you a trick cold, and you've sorted it out, and you are.
I'm just really happy I did my first ever magic trick and also figured out what was going on.
It's also a really easy one to do. Just find 3 dice and shut your eyes, and I love it. It is dead simple, but done, presented well, it can be a nice trick. So there's a Halloween gift to you. Now, I wanted to talk to you a bit more about some non-magic-y stuff, because, well, some more mathsy stuff, because part of what you did quite a lot as for your talks was you pitched yourself as the naked mathematician, and it wasn't just a salacious claim that you were always naked, right? There was a reason. Tell us more about why exposing bits of your body is actually a useful way to talk about maths.
Well, there's 2 things. So the first thing was the sort of, let's call it the persona of the naked mathematician, came about from talking to lots of people who, for whatever reason, didn't engage with maths. So didn't like it or didn't refuse to engage with it. And a lot of the feedback as to why that came back was, it's very serious. So, and that was something that, to me as a mathematician, of course, you got the other things, like it's not for me and the usual things people talk about. But something that really surprised me was, as a mathematician, I'd never considered my subject to be serious, because we sort of see all of the fun in it and the beauty and everything else. But the more I thought about it, the more I thought, that's fairly reasonable. Like, I can understand why some people might have that opinion. And so then I thought, well, how can I not make it serious? I'll just do it in my pants, in short. So that was kind of where the original idea came from. And then it also just so happens that I actually have, I think now 8 or maybe 9 mathematical tattoos. And so when I now perform as the naked mathematician to, of course, adult audiences, should stress this. If I turn up at a school and start taking my class, I'm getting arrested, right? So I'm very aware of I'm very aware that this is aimed at the older audience. But so I do a talk where I actually explain the maths behind my tattoos, and sort of whilst I reveal them during the talk. So it's kind of having a bit of fun. It's trying to show this how can anyone possibly take this serious? And also you can learn a few things about the tattoos that I have.
So tell us about some of the tattoos. We've got I reckon 5 minutes, and I know that's not a long time, but
no, that's perfect. So I'm going to tell you about this one on my arm up here. So hopefully you can see the start there.
I can see a letter. I think it's the letter E. I mean, I can guess that because I can see the number as well.
0.718 something something something. So it wraps around my arm and it ends right down at the bottom here with 3 dots. So it's the first 120 digits, in fact, of the number E. Now, what I want to do to sort of talk a little bit about this is actually present you with let's call it a hypothetical game show Ben. So you seem to have vanished, but I'm going to just keep going anyway because
I'm still here. Sorry, I didn't mean to disconcert you. I wanted people to see your tattoo, so I just.
Oh, because it needs to be big. All right, I get you now.
Yeah. I'll disappear,
right,
but
so,
if you want me back, just say. All right.
Okay. Well, I think so. I'll talk as though I'm talking to Ben, but I'm talking to the whole audience. So this is like Ben having taught me a trick. I'm going to give him a prize, and he's going to have a choice of the prize that he would like. In this hypothetical situation. Well, I say hypothetical, I actually do have the money to give you. So, and again, if you want to think about this yourselves and just type in the chat whether you do A, B, C, D, then you can.
Oh, so 4 options. Okay.
Option A is going to be, I will give you £3. Right, yes. And I've actually got, I'm not skimping here, I've literally got £3. So there's 2 £1 coins and 2 50p's.
Does that pay for the postage to get them to me as well?
Yeah. Right. So you have £3, or you have another option, which is to take £1. And then what I'll do is I will give you 1/12 interest. So whatever total you have at the end of each month, I will add on 1/12 to that, and we'll do that every month for a year. So £1 plus 1/12 in interest. And we'll do that every month.
Okay, so 12 times for a year.
Every month, right, for a year. And then you get the amount that's left at the end. Then option C, we're going to do the same, but now I'll give you 1/52 in interest. And obviously you're going to get that every week now.
Ah, okay. Oh.
So you're getting a little bit less each time because it's a 52nd instead of a 12, but you're obviously getting it more often. Because you're getting it every week, so 52 times. And then the final option, because I'm feeling really generous, is well, am I? You don't know yet. I can do £1 plus 1/365th interest, and that's going to be every day for the year as well.
So it's clearly not a leap year, and you're just shortchanging me, or it is a leap year,
well,
and you're actually
we're assuming,
scamming.
We're assuming the more common situation of the non-leap year.
Fair enough. Okay, so I get to choose one of these.
Number of days. Yes, so you can pick one of these, and I guess the idea, I suppose, here is that you would potentially like to maximize the amount of money you take home.
I should say, anyone watching not in Britain, £3 is like my entire income these days in this freelancing world. £3 is about.
So do you want your yearly salary, Ben, or do you want a third of it, but with some potential interest?
It's tough, isn't it? Because I know that adding a 12th every month is like, this is interest. This is compound interest. Like I'm going to get a 12th, so I'm going to get 1.12 after the first month, I think. But then I've got a 12th of that, and suddenly my mental arithmetic is finding it much harder.
Yeah.
And that's going to happen 12 times. Or I can have a smaller amount, lots and I feel like the power of compound interest, I know it grows. So I feel like D, I want more compoundings. I want more iterations of. So I would like to take option D. I'm a little worried about whether it'll beat option A now. Hold on a second. Okay, I've gone for D.
All right, we've gone for D. So you're thinking D or A. So I actually like the way you've explained this in talking about compound interest, because as you say, it's a very powerful tool, this idea of compound interest, and the fact that, as you say, you get 1/12, so you get 1.12222, but then you get a 12th of that. So that's even more than the original 12th that was added. So it does begin to build up as you keep doing this. So what we can actually do is you can figure out what these, the formula for these would be. So in part B, or option B, what you've got here is actually 1 plus 1/12, and then that's being multiplied by itself 12 times. So you can write it as 1 plus 1/12 to the power 12. And then similarly, for part C, this is going to be 1 plus 1/52 to the power of 52. And then for part D, 1 plus 1/365 to the power of 365. So now we've got actual formulas. You can stick these in a calculator, and you can, of course, figure out what these numbers are.
Yeah, I'm a bit worried now.
So if we do this, B will give you £2.61. So you're definitely right not to choose that. That is definitely less than £3. C will give you £2.69, and D will give you £2.71.
Wow,
So
they're
I'm
really
afraid,
not that different, are they?
Yeah, they're very close. So you had a complete right way to think about it, just accept it just turned out that this one didn't quite go more than £3. So then the question becomes, there's a pattern here between these B, C, and D. And you could actually write this. Oops. So I won't give away exactly what's happening, but what you can think about as my final take-home sort of takeaway message for you all to think about is to say, well, what we're doing here really is 1 plus 1 over n to the power n. So this one is n equals 12 for option B, then it's n equals 52, then it's n equals 365. So if I were to say give you interest every second for a year,
or every half second, or anything you want to pick, right?
Yeah, that would be n equals 31.536 million for every second. And then you would plug that number in, and what you would get for every second is £2.71.
Which sounds like a number we've referenced. I mean, it sounds like my option for D.
Yeah.
But I feel
yeah,
like
so
I've
it's actually
seen
the
that.
same. So even though it looks like paying it more often is giving you more money, there's some limiting value. So if you fully do it, the limit as n goes to infinity of this number is E, which again is the number that's on my arm. And so that's 2.718. So you never quite get to £2.72. You're stuck on £2.71 forever, because I can't give you a part of a penny, unfortunately.
And I remember the first time I came across the number E at school, I was like, oh, it's just another one of those annoying numbers. But then the surprise, which you've kind of picked up on again for me here, is that it turns up all over the place, which is presumably why you tattooed it on your arm. It wasn't just, just one of them.
Well, when people see it, they often think, oh, is it pi? Because, you see lots of numbers and an infinite decimal.
Some people in the chat was like, oh, it's pi,
I'm an applied mathematician. I do calculus all day long. Calculus, E is like to calculus what pi is to geometry. And and also is this limit as well on this kind of growth.
Lovely. Tom Crawford, thank you very much. Is there anything else you want to plug before we leave it? Because we are at 1 o'clock and the next guest is ready to roll. But anything you want to plug? I mean, you've mentioned your website, which I think was tomrocksmaths.com. Anything else you need to say?
Everything is just, all I would say is if, do have a look on my website. I think I've almost got 1,000 posts on there. So there's like articles, puzzles, podcasts, videos, all kinds. And if you do want to just have a chat about maths, like just drop me a message at tomrocksmaths on Instagram, Twitter, Facebook, whatever you want. I like chatting to people about maths, I'll be honest. So
well, we've loved chatting to you here, Tom. Thank you so much for getting involved. Thank you for being the victim of a trick instead of performing a trick. And I'm really glad
well, no, thank you for teaching me. I'm gonna use this now. I feel like I'm now a maths magician. This is awesome.
It's the beginning of a slippery slope, my friend. Can we have a round of applause from around the country and around the world for Tom Crawford? Thank you very much, Tom.
Thank you. Cheers. Bye-bye.